God, you got to love Michael. Thank God he's retiring, I swear. You all know Michael Busha, the guy running to the back there? No? Mike, wave your hand. Mike Busha. Mike has been our Regional Planning Council Director for what, 30 how many? He's been with the Regional Planning Council for 37 years. He's retiring this year, which is really unacceptable, but he is. Anyway, welcome everybody, good morning. Welcome to our Regional Biosolids Symposium. First and foremost, I would very much like to thank the Regional Planning Council, Treasure Coast, and the Indian River Lagoon National Estuary Program for hosting us this morning and helping us put all this together. It's a real privilege to have them both here and to be a part of both of it. So for both of them, please, let's have a round of applause. And good morning, I am Commissioner Doug Smith from Martin County. I'm also a board member of the Treasure Coast Regional Planning Council. And some years back, this crazy guy in the room came to me and said, Doug, we have a real issue that we need to talk about and we need to have a conversation. And we need to understand if there's a better way of doing what we've been doing and can we get it better. And for those of you who don't know him, his name is Gary Roderick, and he is to my left, your right. Gary. I had the privilege of working with Gary for probably 10, 12 years at Martin County. At least? Too long. And the amazing thing about Gary, we had this amazing start to my career doing what I've been doing as County Commission. We had this environmental water restoration department that Gary and Paul Millar headed up for us at Martin County. And it really led off to an incredible run of probably now almost 18 years with the follow-on of Deb Drum, who's also in the room. I just saw her somewhere. Where's Deb? Deb, good morning, Deb. Palm Beach County stole Deb. Thank you very much, Palm Beach County. Nice job, guys. But we had a really incredible run, and we continue to have that run on doing water quality projects in Martin County, and it's been an amazing effort, and it really was kicked off part and parcel with the efforts of Gary Roderick. So Gary, thank you for all that you've done for us, and to continually challenge me and challenge us as a county and a community, as a state, to even get it better. The one thing I reminded him of, and this is classic Regional Planning Council, if in fact it was them who put the poop on your tabletops, it is not for spreading on your bagel. That is not something you want to scoop on there and put on there, but I thought that was really interesting when I walked in the room and saw those this morning. So anyway, thank you all for being here. This is really quite an amazing turnout. I don't think when we envisioned this to begin with that we thought that we would have so many people be here, but we are really impressed. I am impressed that so many people are interested in trying to get this better and do it right. My hope for today is one thing, to see if we can't understand and figure out the biosolid world and see if there's not a better direction and a better way to get there. Our hope is to find out positive solutions and find out a way that collectively we as a state, we as a region, we as a county can do a much better job. At the end of the day, our environment deserves it, our river deserves it, our ocean deserves it, and we as the people who get to live here deserve it. So we have some amazing people with us today in the room. We have some amazing speakers. And to kick that off, I have the privilege of introducing the first speaker. And this individual I've known for quite some time. I got to spend an interesting afternoon with him in a helicopter after Hurricane Francis and Jean, flying around our region, inspecting what had happened and what had gone wrong and what had occurred. And for decades, this individual has served the state of Florida, in both our region and the northern part of our state's region. And he has really been a remarkable leader in all things water and all things environment. He was an environmental aide to Governor Askew. He was the former executive director of the St. John's Water Management District. He also was the executive director of the South Florida Water Management District. I don't know how many people get to hold the honor of having both of those titles, but it's pretty impressive one way or the other. And he also was the legal rep for the State Department of Natural Resources and Planning Agency. He also now, in his current tenure, is a county commissioner from St. John's County up in the northern part of our state. So with no further ado, it was my privilege to introduce to you Commissioner Henry Dean from the wonderful county of St. John's. Henry? Welcome to my living room, Henry. And by the way, as Henry's coming up, again, additional thank you to Indian River State College for hosting us today. This is a great venue, and we're really fortunate in Martin County to have them with us and to be able to host events like this that really are important to our region and our state. But no further ado, okay. Commissioner Dean, how are you this morning?
I'm good. Doug, good morning. To see you, buddy. Come on up. Yep. Well, good morning to all my new friends and some of my very old friends who I have bumped into earlier this morning. Well, I thought I might not even get to speak this morning. I've got a bum left knee, and when I looked over and saw no steps, there's no way I was going to jump that level. I could have done that when I was 20 or 30, but anyway, there's going to be, I think, a great day for the interchange that you are about to have, the dialogue on a very, very important topic. Like Doug, I want to also thank the Indian River Lagoon Council and the Treasure Coast Regional Planning Council for hosting this, and also the college for sharing their conference room. I'm going to, normally many of you who know me know I usually give somewhat of an extemporaneous speech. The staff would spend hours writing detailed notes, and I would toss it away and stand up and just ramble like James Joyce, stream of conscience. But Michael has prepared some very key points for me to consider. They're so good and they're right on point that I want to try to follow this, because these are, I think, provocative points that are going to play right into your panel discussions and your deliberations today. So if you will, allow me. Many of us go about our business every day. We pull the handle to flush and never give much thought to where it goes, how it is processed and disposed of, and what it takes for our public utilities to deliver 24/7 wastewater service at a cost we all can afford. So one of the functions of this symposium, probably the key function, is to have our utility directors provide some insight and education into these and other issues, so we can all begin to understand and appreciate what so many of us take for granted, because these guys do such an amazing and vital job. Now, one of the byproducts, obviously, of the wastewater treatment process is called biosolids, or the wet sludge that is left behind after the initial processing, which is then collected for further treatment and processing. Some of us know a lot about biosolids, and some of us know very little. I'm in that latter category, by the way. If you know my background, I was on the front end of the pipe, not the back end. Water supply, potable water, not wastewater. But now that I'm a county commissioner, I am forced to try to learn a little bit about the back end for obvious reasons. In Florida, our biosolids are either land applied or as a soil amendment to improve agricultural productivity, or buried in our landfills. Either way, it is an important source of water, energy, nitrogen, and phosphorus resources that some suggest could be used more efficiently. And my goal, my personal goal for Florida, is someday to actually figure out a way to turn a profit. And I know there are some ideas being circulated, some of which may be discussed today, about how that might be achieved. The symposium is intended to give us all a better understanding of what biosolids are, what they are composed of. Everyone look at your little table memorabilia. You see that? Don't eat that. Take it home with you. Give it to your kids. Also, what the different kinds are, how they are processed, how much are being processed for disposal and reuse, and where they end up in Florida. We all live in a sensitive watershed, or watersheds, to be more comprehensive in this area, although I've always considered Stewart sort of ground zero if you want to talk about trying to balance Florida's growth with agricultural activity, urban development, estuary protection, Lake Okeechobee discharges, Everglades, you name it. It always seems to sort of all roads lead to Stewart instead of Rome, to say, how do we solve all these problems? So this symposium is also intended to begin a conversation about what, if any, avoidable impacts there are related to our current management of biosolids. We care so much about it. We have spent literally hundreds of millions of dollars to date to restore our coastal estuaries, Lake Okeechobee, the Everglades, Tampa Bay, the St. Johns Upper Basin Marsh, just to name a few. We have established basin management action plans, BMAPs, with lofty water quality goals, and we are and will be spending billions of dollars to get and keep our water bodies productive and clean. Yet sometimes I think we can be our own worst enemy when it comes to managing our activities and watersheds. Probably the least we can do now is no further harm, and we don't shoot ourselves in the foot by adding additional nitrates and phosphorus in the water upstream, which, by the way, are the same constituents that we are obviously trying to remove downstream in all of our lakes, rivers, and estuaries. What is the potential of our current biosolid practices to contribute excess nitrogen and phosphorus to our surface and groundwaters? Could better managing, tracking, and processing be one of the very accessible and significant factors that will help us meet our water quality goals, or TMDLs, that we are all working together to achieve in our various watersheds and water bodies? Can we amend our current practices and process our biosolids to make more clean water and energy and purer forms of more plant available nitrogen and get it to the farmers that need it at a more affordable price? Can we separate out the phosphorus and more efficiently get it to the places in the world that really need it? So my thought is this symposium all comes down to, is this an opportunity to focus on these and a couple of other key questions? Do we need to do better with the management and processing of our own human waste within our watershed? And if we conclude we do, can we do a better job, and how can we do it more cost effectively? That, in essence, is what the final panel is about, to expose all of us to some new technology that has the potential to make better, more efficient use of our biosolid resources going forward into Florida's future. Let's face it, we're not going to produce less and flush less in the future. Today, the Treasure Coast region's 2 million people generate about 222,000 dry tons of biosolids each year, and 30 or 40 years from now, that total will increase by 50%. So how much more of this valuable resource are we going to put across the watershed? And how much more valuable landfill space can we afford to take up by disposing it there? I think all of us, as either local elected officials or appointed professionals, caretakers of our fragile economy and environment, and managers of our public funds, need to begin a serious conversation with our utility directors and others about what does the future of biosolids management look like in 30 years. Is it the same as we are doing now, the status quo, or is it something completely different, using new technology to create more strategic and valuable reuse products? So that's the challenge we need to take up today. And I'll leave you my advice from my kindergarten teacher, which is also, I think, the advice that leads to universal world peace and that you entertain today. And as you go forward in this discussion, and that's be nice to each other. Have a good civil discourse, guys. There's a lot of brain power in this room, by the way. Experience-wise, I thought, if we have 160 participants, that's probably somewhere between 3,000 and 4,000 years of experience when you think about it. And with this brain power, hopefully you can come up with some good recommendations and hopefully, even more importantly, implement them. Thank y'all. Appreciate it. Thank you.
Well, thank you, Henry, and thank you, everybody, for coming out. I'm going to introduce the first speaker today, and you know, when we started the notion and considering to do a symposium like this, Maurice Barker's name just kept coming up over and over again. Maurice knows everything about biosolids. He knows the who, what, why, where, when, how much biosolids there are, where it's going. And so automatically we knew he was our Biosolids 101 guy. So I'm very grateful that Maurice made the trip down. It's a long way from Tallahassee. And I'm thankful to the Florida Department of Environmental Protection for allowing him to come down. For Maurice, I guess the last 20 years, he served as the Biosolids Coordinator for FDEP. He also serves as the on-site treatment and disposal system liaison for the Department of Health. So with no further ado, I'd like to give a warm welcome to Maurice Barker, a warm Treasure Coast welcome. So thank you.
All right, good morning. I know that for the introduction, I had a voicemail. Michael was trying to talk to me so he could give some personal information in his introduction, and I successfully avoided that by having a new AC unit put in my house and not being available, and then traveling yesterday. But I figured Facebook had already probably given out enough personal information. I didn't need to give more. But if you notice in my picture, I have one of my dogs. I have 3 dogs. And so if you want a personal thing, every morning I always have coffee in the backyard with the dogs before I go to work. And even though I couldn't do that this morning, I do have hair all over me from the dogs, so I did bring them with me. So in a way, I had coffee with the dogs this morning. So I'm going to give you a quick overview of biosolids use in Florida and the regulations that apply. I'm going to be a little bit quick on some of the slides, but I'm sure later today we'll have plenty of time for questions. Is this on? Okay. All right, so what are biosolids? Well, when a wastewater treatment plant treats sewage, it comes out with really 2 end products. Effluent, the treated effluent, and the biosolids. And as I always tell our staff, biosolids are actually the more visible of the 2 and will draw more attention. Okay, so they are the solid, semi-solid, or liquid material produced from wastewater treatment plant. As the biological process goes on, the microorganisms die, and those have to be wasted periodically. The term biosolids is actually defined in most modern dictionaries as the solid organic matter recovered mainly for fertilizer. We use biosolids to mean all the material, whether it's treated or not. I know some states only want to refer to biosolids as the treated material. We just found that with the term, we used to use the term domestic wastewater residuals. Most people didn't know what those were. We had never used the term sewage sludge, and what happened was over the nation, the term biosolids just became the common term, the most easy one if you want to find our regulations. So we shifted to the term biosolids. Okay, now when a wastewater treatment plant treats its sewage and comes up with biosolids, it has a number of options that it can consider. Most facilities in Florida, because we have a whole bunch of small facilities, they transfer their biosolids to other facilities for treatment. It's not cheap to treat the biosolids. Can you hear me? Am I holding it close enough? It's not cheap to treat the biosolids. And when you get larger facilities, you have the economies of scale. And so for small facilities, it's really not worthwhile. They're actually probably paying the most per unit cost per dry ton in transferring their biosolids to other facilities. Landfill, biosolids can be landfilled. We put in every wastewater treatment facility permit the option to landfill their biosolids. But one thing we don't put in is the landfill can't take liquid, so these biosolids have to be dewatered, then transported, and there's tipping fees. But just a word on landfills. Landfills do not have to take biosolids, and only a small percentage do. And those that do take biosolids, they operate on a rough rule of thumb of they only want 10% of their volume at most a day to be biosolids because it comes in as a wet, muddy material, and that's hard for their equipment to work with. So for those landfills that do accept biosolids, they probably don't really want any more. Next, I just want to say land application. A facility can treat its biosolids to a certain level of quality, and then they can beneficially use them by land applying them out on controlled sites under DEP permits. Then if they want to treat it to a much higher quality, they can distribute and market it as a fertilizer. That's what we call Class AA biosolids. Incineration, we actually do not have any incinerators in Florida right now. Those all went away back in the late 90s. Jacksonville and Pensacola had the last sewage sludge incinerators, but that is a legal option if someone wanted to do it. And then bioenergy, and I put potential because our concept when we first started talking bioenergy back in the late 90s were processes that basically consumed most of the biosolids and you had very little left. But there are a number of processes that have been looked at. So we just mentioned that, but there really haven't been that many viable ones that don't come out with a lot of biosolids still left over that need to be either land applied or distributed and marketed. So, and we put in each facility permit. Okay. All right. We put in each facility permit what the facility is allowed to do. So here's just a rough breakdown of the biosolids in Florida. We estimate that there's about 340,000 dry tons of biosolids produced each year, and that's raw biosolids. That's not final product. There's a lot of Class AA material, compost, some of the alkaline materials where a lot of materials added into it, and then what we get reported back is that final volume of material, but we like to also know what the raw biosolids production was. So that's what that estimate is. And for years, for like the last 5, 6, 7 years, it's been a pretty good breakdown. 1/3 has been land applied, 1/3 has been distributed and marketed, and 1/3 has been landfilled. It's kind of been shifting over this last year to a little more distributed and marketed, and probably a little bit less landfilled. And then we do get shipments from out of state. These are primarily, well, they're only pellets. And right now, it's down to just 10 to 20,000 dry tons a year. Back in the early 2000s, that was around 100,000 dry tons a year. Okay. So I mentioned a little bit about Class AA and Class B. So there are 3 classes of biosolids allowed under the regulations. Class B is the lowest quality for beneficial use. And that's what we see. That's for the land application. Class A is a category we have, but we really don't see that. Basically, that meets Class A pathogen reduction, but it doesn't necessarily have to meet the stricter metal limits of Class AA. And then we have Class AA, which is the highest quality for beneficial use. So I mentioned land applications Class B, distribution marketing as a fertilizer is Class AA. And if you look at the federal level, you'll hear a term Class A exceptional quality. That's what we have defined as Class AA. The reason we really don't have any Class A is if they provided that Class A pathogen reduction. Biosolids in Florida are generally low in metals, so they really already meet. If a facility is providing that level of treatment, they're going to qualify for Class AA biosolids, and why not take advantage of the distribution and marketing options for the Class AA. Then the rules, the rest of the rules are kind of based on what you want to do with it and what class of biosolids you're going to produce. And it's designed to really protect from 3 things, the pathogens, the nutrients, and then the other pollutants that might be in the biosolids. Okay, for treatment, I mentioned the Class B treatment. That is treatment to significantly reduce pathogens. And then the Class A or Class AA treatment basically virtually eliminates pathogens. And then whether it's Class A, AA, or B, it has to meet a vector attraction reduction option. That's to reduce its attractiveness to birds, rodents, insects, so that any potential pathogens in it won't be transported off-site by those vectors. And then for Class B, because there are potentially pathogens remaining in the material, there are a number of site restrictions in our rules that help to protect for pathogens from Class B biosolids until those pathogens have a chance to die off in the environment. Okay, nutrients for land application. Nutrients are limited to the rates that the crops need. There are some phosphorus restrictions in certain areas of Florida. It's basically based on statute. Land application sites have to have a specific site nutrient management plan, and we'll talk about that in a little later. And then there's a number of site restrictions that help to minimize the nutrients. We have slope requirements, we have setbacks from surface waters, we have a minimum depth to groundwater. These all help to minimize the potential impacts from nutrients. And then Class AA biosolids, they're not normally land applied because since they have that option to be distributed and marketed as a fertilizer. So they are not subject to the same nutrient restrictions that Class B are. And they are basically into, and that's what we'll talk about in a minute, they've basically been pushed as much as we can into the fertilizer world. I'm still trying to figure out where to point. Up at the box, okay. I was wondering, okay. So, for the pollutants that might be in biosolids, our rule is based on the federal rule. There's 9 metals that are regulated. This came from an extensive EPA risk assessment. Those are the ones that they determined appeared in the biosolids frequently enough and at a high enough concentration to be a potential health concern or a concern to the environment. There's 2 sets of limits. There's the how much of these pollutants can be in the biosolids themselves, and there's 2 subsets of that. There's ceiling limits that both Class B and Class AA have to meet, and then there's the more restrictive Class AA limits. And then for land application, there's a site lifetime limit on these metals, how much can be applied to this site before they have to cease land applying. And because most of the metals in biosolids are fairly low, and we require on-permit applications for sites that they predict how long they can use the site. It's typically in the 200, 300, 700 years that they can continue to use the site before they meet one of the cumulative limits on applying biosolids to the site. And then again, a number of those site restrictions we have, the site slope, the setbacks, all help to minimize potential impacts to pollutants in the biosolids. Okay. So there's multiple levels of regulation of biosolids in Florida. At the federal level, it's Part 503. And we are not delegated Part 503, so EPA Region 4 and EPA Region 7, they have a Center of Biosolids Excellence there. They're the ones that enforce 503 in Florida. We have our own state rule, Chapter 62-640, and it's primarily based on 503, but it also addresses a number of additional things that 503 does not address, some new and some that were historic in the earlier biosolids regulations that have carried over. And then the third level is local ordinances. Now, DEP, we do not enforce local ordinances, but do not underestimate the impact that local ordinances have had on biosolids activities in Florida over the last 20 years. Okay, I mentioned Part 503. It was a long rulemaking effort by EPA and still recognized as probably one of the most extensive risk assessments that EPA has ever done for a rule. They looked at 14 different exposure pathways, whether it's applying the biosolids to land, uptake in crop, exposure to human, to land, to animal, to human, a lot of different ones. One of the ones that a number of the AA limits are set on is a child actually eating the biosolids. So that's what most of the limits for the pollutants are based on. For the pathogens, they're technology-based limits, standards. A lot of the Class B processes that are approved came from the old Part 257, the solid waste rules at EPA. Let's see. I mentioned that we aren't delegated. Very few states are delegated Part 503. EPA made it kind of a very burdensome process to get delegation of 503. And that's fine with us, and now that just means there's two entities regulating biosolids in Florida as far as the state and federal level. Now, one thing about 503, it does not address phosphorus at all. Its agronomic rate that it allows is based on nitrogen. And every 2 years, EPA reviews their rule to see if they need to update it. Okay, for Florida's regulations, they originated in solid waste rules back in 1984. In 1991, Chapter 17, 640 was adopted. EPA was working on Part 503 at the time. That was going to be under the Office of Water at EPA's level. So 640 was going to come under the Division of Water. It made it through faster than 503 did. So then when 503 came out in 93, Chapter 62, 640 was revised in 1998 to be more consistent with the final version of Part 503. There were some minor differences. The original 640 had a Class C type of biosolids that was going to be under the federal rule, but then it did not make the federal rule that came out in 93. So things like that had to be updated. There were more metals in the final 503, so those had to be added to the rule as well. Okay, some of the key differences. We actually issue permits. EPA doesn't. We issue permits not only to the facilities, but we issue them to the sites. We require a nutrient management plan. EPA does not. We have phosphorus provisions in our rule. EPA does not. And then we have a number of additional management and site restrictions in our rule that EPA does not have either. Okay. So now, one of the more popular uses, well, let's move on to that. We're going to talk about now Class AA biosolids, and then I'll talk about land application in Class B biosolids. So, basically, Class AA distribution marketing is the sale or giveaway as a fertilizer without any restrictions on the end user. We enhanced our rule in 2010 to help push AA more into the fertilizer world. And that's a later bullet here, but basically we require them to be distributed and marketed under a fertilizer license or to someone with a fertilizer license. And that way they'll fall under that fertilizer world. And I don't know if you've ever looked at the DAX fertilizer tonnage reports, but a number of utilities are showing up on there, on that report. Some don't. I know one of the ones you'll hear about today, the Palm Beach Pelletizer run by New England Fertilizer. They sell all their pellets to fertilizer brokers and fertilizer blenders and fertilizer companies. So their pellets are showing up on that report, but you just won't ever see them because you'll see they'll just be included in the tonnage for Diamond Fertilizer or Griffin Fertilizer or Florida Fertilizer Company. Okay, we have about 39 facilities in Florida that produce Class AA. I say approximately because every year we seem to lose one, and every year we seem to gain one or two. So it's this constant back and forth. You know, some utilities, they do a AA product for years, decide that, you know, as they're reaching the equipment lifetime, that they don't want to do it anymore, and so they'll back off and go back to either Class B or landfilling. We have a wide variety of treatment processes, and we do see a slow, steady trend in the increase in Class AA. Okay, I mentioned we have a wide variety of processes. It turns into a large variety of products. We have pellets, which I think the public is the most publicly acceptable ones. Heat dried is similar to pellets, it's just not uniform. Compost. The ATADS, that is a liquid biosolids product. So don't think of AA as just pellets or just compost. There's anaerobic digestion processes. There's also a BCR neutralizer, chlorine dioxide process. And then we have a number of alkaline-based processes, Bioset, Enviro, and we actually do have a facility that does lime pasteurization. It is probably the least publicly acceptable of the AA processes. Okay, just a picture of pellets. I'm pointing at, okay. That was just kind of a comparison between an old Class B and some heat-dried material. And then various other processes, the composting, that was an in-vessel composting, and then high temperature, high pH processes, the alkaline processes. Okay, this is just a map of the AA facilities around the state. The three major populations in North Florida, Pensacola, Tallahassee, and Jacksonville all have pelletizers. ECUA also in Pensacola has composting as well now. Just a number of facilities that are producing it. Okay. For 2016, I have compiled those numbers. There was 191,344 dry tons of final Class AA product distributed and marketed in Florida by those 39 facilities. Note, that sounds like more than 1/3 of 340,000 dry tons of raw material. Remember I said that a number of these AA processes, like compost, adds additional material. We actually have one, I was talking to somebody earlier, one facility only adds a little bit of biosolids to their compost. So that final tonnage is a little bit deceptive. It's deceptive for other reasons too. Some facilities stockpile for a little while and then distribute it all in one big quantity, so they may actually have some from 2015 they did in 2016. It all depends. And then there was actually some Florida biosolids distributed and marketed out of state, just a little bit. And then we have 5 facilities that shipped biosolids into Florida at about just under 10,000 dry tons for 2016. This is just a breakdown. I know it's hard to see, but a breakdown of facilities in South Florida that produce Class AA. Hollywood does Bioset. I know Miami-Dade does just a little bit of compost. Palm Beach, the New England, the pelletizer run by New England Fertilizer, that produces 21,000 dry tons of pellets. And like I said, that's pretty much all sold to fertilizer companies. So really, for the number of facilities down here, Lee County over on the West Coast does composting, but for the number of facilities, not as many do AA as probably could be doing it. I know Miami-Dade has been playing around with the idea of doing AA and has been having a number of projects looking at it, but they still do Class B and landfilling, addition to their little bit of AA. Okay, so land application, we can talk about that now. It's basically the application of Class B biosolids. We'll say Class B because that's really what it all is. At a permitted site that follows a nutrient management plan and meets all of our site restrictions and requirements. Why is it land applied? Because it contains the nutrients the crop needs, primarily nitrogen and phosphorus, but it also contains some of the macronutrients that the crop needs as well. And one of the big benefits is the organic matter that it adds to the soil. A lot of Florida soils are very sandy, and they can really benefit from the organic matter in the biosolids. And this is one of the big advantages of biosolids. There are actually about 140 land application sites right now permitted in Florida. Haulers are generally the primary permittee for these sites. There are a few that are done by the site owner. But basically, a lot of large utilities will contract with a large hauler. The hauler has the agreements with the landowners, and that's how it tends to work out, that the landowner doesn't want a DEP permit, so the hauler gets the DEP permit and has the arrangement with the landowner. Okay. Now, how we regulate, we treat and we permit both the treatment facility and we permit the land application site. We permit the treatment facility because they're the ones that are generating the biosolids, providing the treatment for the biosolids, monitoring the quality of the biosolids. And for AA facilities, there is no land application site, so we have to make sure that the material is Class AA by the treatment facility. And there are no restrictions on the end users. For the site permittee, we permit them to make sure that their site meets the requirements, that they have a nutrient management plan, that they're following their site restrictions, meeting their setbacks, keeping their records, and then they report annually to us the loadings on those sites. Okay, so now the permitting, the actual formal permitting started, it came about in the 2010 revisions to the rulemaking and was implemented by 2013, where each site has to have a formal permit, an individual permit. If a facility is the only facility using the site, then that site can be permitted under the facility permit. All that really does is save them the $1,000 permit fee for it. But they have a form they have to fill out. They have to submit a nutrient management plan. Part of that nutrient management plan, I have a slide on it, they have to do a phosphorus assessment. They have to do soil fertility testing. I mentioned they have all these site restrictions that they have to meet. And just to give you an idea, you know, site slope in Florida, most of Florida is flat. A number of states have site slopes, but to us, anything over 3% is bad, and nothing's allowed over 8%. You go to Virginia and Pennsylvania, and that goes up to 15%, 20%. So we're lucky that we have flat sites in Florida, but everything's put in perspective depending on where you live. And again, I mentioned that the site permittee does not have to be the landowner. We opened that up. But here's an example, just a map of a site up, and this is a site that straddles Osceola County and Brevard County. It is got 30 application zones. It covers almost 6,000 acres. I like to show this one because, you know, for an inspector who's going to go out there, he's not going to be able to inspect all 30 zones during his inspection, so he has to prioritize where he's going to go. But this is an example of the complexity of the sites. And the odd shapes of all those zones are because of the setbacks to either sinkholes or surface water or wetlands. So there's a lot of detail that goes into the permitting of the land application sites. We mentioned the nutrient management plan. It has to be done by either a certified nutrient management planner or by a professional engineer. It identifies the zones, it identifies the crops, how the M&P will be implemented. Any tissue testing or any soil testing, now that only has to be in there as applicable. If they're basing their rates on some of those results, then they need to be part of the NMP when they submit it. But really, the application rates are the heart of the NMP. And we do have a requirement for them to consider the migration of phosphorus off the site. The only tool out there right now is the Florida Phosphorus Index. I think I have a separate slide on that. But basically, they have to take into account all nutrient sources to the site and to their zones. There's a couple other things they have to do. Realistic annual yield goals. If they're going to base their rates on harvesting, then they have to have a realistic goal. And I don't know how I'm doing on time. So anyway. Actually, I might get there. Okay, the P index, this is something that came about with the nutrient management plan. It's used by NRCS. It was developed by them with the help of stakeholder agencies and primarily University of Florida. The IFAS professors did a lot of work to develop this. The current version was adopted in 2004. It basically looks at both runoff and leaching and tries to assess the risk for migration of phosphorus off the site. We thought, and I think the IFAS professors thought, that this was going to be a real hindrance to a lot of land application sites. Unfortunately, and it's something that NRCS wants to update, it's very slanted towards surface water runoff and not so much on leaching. And with Florida's sandy soils and flat sites, leaching is probably a bigger hazard than surface water runoff. It's something that, you know, we would like the P index to be updated, but because of that, it really ended up not being as big of a hurdle for land application sites that we thought it was going to be. Okay. For land application sites, they have to keep records of everything they receive, every application they make to each zone. There has to be a site log for the zones. During that site log, they keep a running tabulation of the nutrients added to that zone. Those are required to be kept on site, so if an inspector goes out there, they can see when the last application was, what their current nutrient loading is. They have to track the metals annually that they've loaded to the site to make sure they're under those cumulative loading limits. There's some things in there, tracking of biosolids off-site prohibited. That's because back in the early 2000s, we had a lot of complaints about when the trucks left the site, they dragged biosolids onto the road afterwards. So those are in there. And we not only conduct site visits prior to permitting a site, but we have routine inspections, and we do complaint investigations and normal compliance and enforcement. Okay. Just some of the setbacks, 1,000 feet to outstanding Florida waters, 200 feet to surface waters, setbacks to private water wells, to residences occupied by the general public. If you compare these to setbacks in some of the best management practices for fertilizers or manure, you'll see that these are much more stringent. The EPA setback for biosolids from a surface water is 10 meters, which is 33 feet. So that's a comparison. Okay, again, we have the restriction depth to groundwater, runoff provisions as a site slope, can't use a frequently flooded site. They have to maintain the site pH at 5 or above. There are a number of Class B restrictions because of that potential for pathogens to remain when they're first applied to the site. There's public access restrictions of a year, harvesting restrictions depending on what crop is being grown there. And most of our sites are either pasture or hay crops. They can be used on citrus or sod. There's grazing restrictions for cattle, and in 2010 we updated, and molybdenum, we have not a limit for molybdenum, but when that amount gets reached, then they have to let the owners of the cattle know that there's a certain level of molybdenum at that site, so the cattle don't develop molybdenosis. We have some additional requirements in 2010 on alkaline treated material that has to be applied right away. We have storage restrictions. We have advisory signs that we enhanced in 2010. This, and you're probably familiar with this, the Northern Everglades statutes. In 2007, there had originally been 43 sites in the Okeechobee, St. Lucie River, and Caloosahatchee River watersheds. As those sites came up for, the facilities using those sites came up for permit renewal, they became applicants, which is how this was enforced, and these sites are all gone now, all phased out over the 5 years after that. So this slide, just as a thing that I don't know if you've heard, but in 2010, they passed a bill that was going to prohibit the land application of septage by 2016. Affected about 80 to 90 septage management facilities around the state. It applied to the DOH statute, Chapter 381, and our facilities are permitted under 403, so it did not apply to our facilities. Under our rules, basically septage is regulated like as biosolids, and since 2016, we have permitted 42 septage management facilities in their corresponding sites. Okay, just to let you know, facilities are trying. There have been alternative technologies tried over the last 10 years in Florida. City of Sanford and Max West tried gasification. They were working on it. It didn't prove viable before Max West, I guess, ran out of money. So that is no longer operating. Max West filed for bankruptcy. It's my understanding the only equipment there at Sanford is the building that they auctioned off all the equipment, and it's been moved out. Orlando, City of Orlando tried supercritical water oxidation. From a news article, I guess they suffered an explosion back in 2014 because it is a very high pressure process, and they have not, to my knowledge, tried to restart that. We do have some anaerobic digestion. We have some older facilities that make some use of their methane. There's a facility in Orlando, Harvest Energy Garden, that accepts a number of other organic waste in addition to biosolids. And their final material, I believe, is heat dried and made into pellets. So they still have, the issue I brought up, there's still a certain large volume of biosolids left after the methane producing process. St. Pete is planning this type of a process as well. Okay, and then waste to energy facilities. You can go on. There's a number that have that option to burn them in their permits. They don't right now. I think 50 dry tons was burned in 2017 as far as I can tell. I think it's just so that that option is there. I don't think they really want to do it, but it's there in case they need it. There are concerns, there are air permits involved and concerns with that. So, okay. Coming up is Jennifer Smith. She is the director for the Southeast District Office, and I believe she has an announcement to make.
Good morning. Thank you, Maurice. The Florida Department of Environmental Protection is committed to protecting Florida's water and natural resources. And vital to our mission is working cooperatively with state, local, and federal agencies, as well as local communities and various stakeholders and interest groups that can provide key input, local knowledge, and additional data and information to help inform our regulatory and restoration programs. DEP is aware of a increased interest in better understanding the nutrient impacts associated with land application of biosolids. And because the department remains committed to using science to guide our efforts, we're creating a Biosolids Technical Advisory Committee. This committee will evaluate current management practices and potential opportunities for enhancements to better protect Florida's water resources. So DEP is currently seeking nominations for the membership on this committee. Membership will include various groups: agricultural interests, environmental interests, local government, academia and research, representatives from large and small wastewater utilities, including the Florida Rural Water Association, biosolids haulers, and the Florida On-Site Wastewater Association. The deadline for nominations is going to be July 6th. There will be a blast email going out statewide, so you guys are the very first to get this information and hear this announcement. That'll be going out later today, and I'm going to work with Michael to ensure that everybody in this room gets that email and gets the email that we have created to gather this information, and that is biosolids_TAC@floridadep.gov. Again, I'll make sure everybody in here gets that email address and the email that'll be going out with this announcement. We will also be this is all very new, but we're going to be working on a web page that will have information for everybody to, learn updates about the committee, times, etc. So, thank you very much.
We have Scott Traynor coming up from the Solid Waste Authority, Biosolids Facility Operation Manager. He's going to lead a panel with our utility directors so we can understand a little bit more and learn a little bit more about what the utilities, the challenges they have, what they're going through to provide the service that they provide, that vital service they provide. And so 1 minute, do you want the handheld or would you like the lapel? Handheld's good.
Good morning. Well, this little portion of our exercise is going to be just to let everybody know what's going on in our counties presently with biosolids. And we're going to start from south to north and start out with Palm Beach County. Mr. Hassan Hajimeri, PE, is the Deputy Director of the Palm Beach County Water Utilities Department, and he'll be letting us know what's going on in Palm Beach County.
Thank you so much. Thank you. Thanks for having me here. It's an honor to be here, and thanks to Mr. Barker for the great presentation. I think we need to get at least 2-3 hours of PDH credit for all the material that we learned today. And also, he covered almost half of my presentation, so I'm going to make it very quick. What are the biosolids? I think we all know what the biosolids are by now. If you have a wastewater treatment plant, you do have a biosolid. And biosolids are, if it's processed properly, it could be very beneficial to the soil, enhancement of the soil, and also taking up spaces in the landfill. I'm going to go very quickly. Okay, thank you. You saw a similar slide. The process flow diagram for the wastewater plant. Let me see if I can get this one right. Great. We do have it original screening, degrading, aeration, clarification, and also the sludge, as it was mentioned earlier, and reuse. So most of our wastewater treatment plant that we do operate in Palm Beach County, they do have some kind of reuse and all produce sludge. But again, I'm going to go on this very quickly. Oh, that one. Class B and Class AA, I'm not going to spend any time on this. It depends on the type of the treatment that they receive. And the product is fertilizer to different degrees and marketed differently. If it's Class B, you have a limited public access. Rest of them, they use for the golf course, agricultural, landscaping. That one, there we go. And as far as the famous Palm Beach County, we are the largest county in the state of Florida, if I'm not mistaken, covering 2,400 square mile, 1.5 million population. Oops, too fast. That one? There we go, sorry about that. Nearly 10% of the population, they have septic tank in Palm Beach County. So about maybe 100,000 people are on septic tank, nearly about 40,000 parcels. We have 18 wastewater treatment plant throughout the county, starting from the Loxahatchee Environmental Control in the north, Seacoast, East Central Regional, Village of Wellington. These are the larger one I'm going over. Palm Beach County, Southern Region, South County Regional, City of Boca Raton, and also 2 Western wastewater plant for cities of Pahokee and Belgrade. Over half of these 18 wastewater treatment plant are very small coastal communities, package plant along the coast, and which they produce probably close to or treat close to 150,000 gallons of wastewater daily. So it's very, very minimal compared to what's being treated throughout the whole county, which is 110 million gallons per day, and about 140,000 tons of sludge being produced. Okay, aim that one. There we go. Those are small communities, wastewater plant. These are the 9 small communities. They send their sludge to the ECR water reclamation facility. This is a 70 million gallons a day treatment facility. Receives about 50 million gallons a day, which it sends as a sludge to Solid Waste Authority. The other larger wastewater treatment plant also send their sludge to the solid waste. As I mentioned, these are the largest, larger facilities in the county. Solid waste, I do receive them, scan the sludge, and typically about Class B sludge, and they send it to the NEFCO. It goes through the treatment process that we were just briefed on, and produce a AA sludge, and it's been marketed. The other remaining wastewater plants was Village of Wellington, that themselves, they produce a AA sludge. And the 2 other smaller facilities at the Belgrade and Pahokee, they send it to the McGill, Brington Organic Compost, and Omni in Osceola County. There we go. This table summarizes the limitation for Class A double sludge, as we see here. And the product that has been produced by the NEFCO, which is the AA sludge, is extremely less than what the limits are. These are the metal, by the way, not the nutrient. And you see that in a fold of 10s or 20 times less than what the limits are. And even our Class B sludge has much, much less metal than what the AA is required. the Class B sludge, the one that we actually produce in our wastewater treatment facilities, has about 4% phosphorus, 3.4% phosphorus, and close to 5% nitrogen. That's what we do in Palm Beach County.
Next up is Martin County. Mr. Sam Emerson is the brand new director of Martin County Utilities and Solid Waste.
Thank you very much, and good morning. It's good to be here, and thank you for the invitation to share with you our story in Martin County. Before I get started, you told me it was that box. There we go. Once again, moving too quickly. That's a little slow. Anyway, before I get started, I want to recognize an individual, Mr. Todd Leland. Todd is our water and wastewater treatment division manager. He's a great guy. When you talk about a good steward of the environment, Todd is the epitome of that. He manages all our water and wastewater facilities, our reuse, reclaimed systems, and also the biosolids management. So I want to thank Todd. Raise your hand, Todd. If you have any questions at the end of the slides, Todd is the guy. If I could clone anybody, it would be Todd, trust me. In Martin County, we've got two facilities. The county underwent some acquisitions over the last few years, acquired some package plants to eliminate problems with those, privately owned and maintained, and now we have two facilities. One is the South Plant, Tropical Farms. It's about 5.9 MGD of wastewater daily, and then the North Plant, which is in Jensen Beach, which is permitted at about 2.6 MGD. Both of these facilities produce reclaimed water as well. We're treating about 4.5 million gallons daily. You all know the constituents in wastewater, but we do have a process to produce a high quality effluent, which is into a pressurized system that serves golf courses, residential properties, and some commercial properties as well. Over the years, we've seen some challenges. There have been some more emerging challenges, even more recently. Of course, one of those is population growth, impacts on the environment, and then what we do with the additional wastewater and also biosolids resulting from that. We serve about 100,000 people currently on our central system. Along with that, we've had to deal with sludge removal, operating costs, perhaps not having a comprehensive vision for sludge disposal or disposal methods over the years and into the future. We've got landfills where we dispose of, having additional restrictions on those, and also the regulatory and inflationary pressures we've seen in treatment process. I know you can do it. We think we're on the right road to a greener and more sustainable biosolids management plan. Up until, well, starting about 1985, most of you are probably familiar with sludge drying beds. We'd take the sludge from the clarifier or digester, it'd be distributed in beds, it would dry out in the open. Once that's dried, we'd collect that, dispose of it at landfills, sometimes land applications. Probably wasn't the best process, but excuse me, this thing is sensitive. Probably not the best process, but moving on, 1997, we began doing an alkaline stabilization to treat pathogens. Most of that was also land applied. And then in 2002, we began a new process of mobile centrifuge, where we had a company, in this case, I think it was Synagro, or one of those companies that provides an on-site centrifuge with a generator to power that. Interesting enough, too, I just done some research to go back through the ordinances over the years, and the commission took action in 2001 to actually establish setbacks from surface water for the application of biosolids and sludge, at the time called sludge, Class 1, Class 2. It was renamed or reclassified as Class A and Class B. So at that point, they put a restriction of 400 feet from surface water to apply Class A biosolids, and then 800 feet for the Class B biosolids. Then in 2002, they actually put a complete restriction on the application of septage in Martin County. We moved on to about 2015. The commission, and being good stewards there of, can you hear me now? I'm not used to holding it. I'd like to have a stand, but fine. But in 2015, the board decided to invest about $14 million in their wastewater system, treatment system, regarding biosolids. And now we have a chemical injection process that we can produce AA, exceptional quality biosolids. And doing that just to be more part of a green and sustainable county, we now have a beneficial use for our biosolids. And as I mentioned, we can produce now a Class AA exceptional quality biosolids. This project was completed in April of 2015 and is currently operational. Today, we're not producing the Class AA. Todd's going through a series of tests, running some efficiency studies, and taking samples of the influent, effluent, biosolids, nutrients, percent solids, and so he's putting together some spreadsheets. If you need to look at a spreadsheet before you leave today, please see Todd. He brought those with him. But that's been in operation since 2015. So the process here I'll describe briefly. Our waste-activated sludge coming off the bottom of the clarifiers is about 1% solids. It's running between 0.8 and 1.3, but averages about 1%. We add some polymer in the process to thicken the sludge to about 4%. We then move that into a process tank. We add ferric sulfate, chlorine dioxide. We then, the next step, after several hours of that, let that mix. We lower the pH and add sodium nitrite. And then we raise the pH, add polymer, and then begin the dewatering process through centrifuge. Todd was being real slick with these, but I'm going to move on through. This is the hand. This is the five amigos. And we're going to start with the first amigo. It's ferric sulfate. We add ferric sulfate in the process to bind up the phosphorus. Next, we add sulfuric acid. We add sodium chloride. These then combine to form a chlorine dioxide for some pathogen reduction. We add sodium nitrite next as a neutralizer, and then also the last ingredient is sodium hydroxide. Todd refers to these three as the three sodium amigos, but that's what develops the punch in the process. I mentioned the chemical process of sulfuric acid, sodium chloride, and then that combines with sodium nitrite to get us to this class of treatment. And real quick, I'll run through some slides. This is a photograph of our South Treatment Facility. This is the biosolids processing unit. This is the sludge thickening equipment. We get that to about a 4% solids at that point. In the back, you'll see 5 chemical storage tanks, and then to your left on the slide, we have some chemical pumps and then also the process train equipment that transfers that sludge then into the process tanks. Tanks are located at the back of the building. They're stainless steel tanks. Hope that didn't make anyone dizzy. Yes. Made me dizzy. I've looked at it about 10 times. So, it then comes from the process tanks. It's treated with polymer. It then goes into the centrifuge, which is circular centrifuge, dewaters that sludge, and then the dry solids go to the top into the hauling truck located in the truck bay. We've been achieving at least an 18% solids content in the end product. We can get higher, but that's about our minimum solids in the end product. As mentioned earlier, there are generally 3 disposal methods or 3 places the solids go. We've got distribution and marketing, which is a preferred option. The second option is land application. Second preferred option, and then of course the landfill option. one of our vendors, our vendor that we utilize to haul the sludge and the solids, then goes, we prefer McGill at this point. They have a composting facility, you've heard that mentioned earlier, in Brighton. They generate a product from that. The other option, which is not the preferred option, is a landfill. And then also land application sites in rural areas. And that's our story.
Next up, we have St. Lucie County, and Pat Walsh is the project manager for St. Lucie County Utilities. Pat?
Thank you. Yep, Pat Walsh. I'm the project manager with St. Lucie County Utilities, and I'm responsible for the operation maintenance of all the water, wastewater, reuse facilities, and associated infrastructure. I'll give you a brief overview of the St. Lucie County Public Utilities Department. There's two divisions, the St. Lucie County Utility, which is the Water and Sewer Department, and the Solid Waste Division, which is the recycling and baling facility at the landfill. I'm responsible for the utility department portion. Our mission in St. Lucie County Utilities is to improve the quality of life in our community by providing safe, reliable, and environmentally responsible water, wastewater, reclaim service to our customers at a fair and reasonable cost with the best customer experience possible. Mission statement. Behind there's an overview of our South Hutchinson Island wastewater facility digestion, where the biosolids are stored. A brief overview. St. Lucie County Utilities was incorporated and created in 1984, where private utilities were acquired by the county and taken over from the private sector into the public entity. Currently, here is an overview of the St. Lucie County. We currently have 500 customers. We operate 5 wastewater treatment facilities, 2 water facilities. We maintain 172 miles of pipe, and we currently have 60 sewage pump stations that convey the sewage from the residents to the treatment facilities. We look at the overview on the bottom portion, the pink portion, that's Port St. Lucie service territory that's maintained by the city of Port St. Lucie. Within that pink, you'll see the little purple there. I believe that's St. Lucie West service districts, who maintains their own water and wastewater facilities. The yellow there is the reserve CDD, which they maintain their own water and wastewater facilities. And on the top, the tan portion is the city of Fort Pierce, which is owned and managed by the FPUA. The light blue portion of the county is the unincorporated area of St. Lucie County, and that is their service territory. The areas out in blue on the beach, you see the blue, that is the North Hutchinson Island, where we maintain water and wastewater service out there. The county owns the water transmission and collection, and also the wastewater facility. The water is provided through a bulk water agreement with FPUA. On the South Island, the area that is green, shaded in green, from the Fort Pierce city line down to the Martin County line, the wastewater infrastructure is owned and operated by St. Lucie County. The water service for the residents on the island is provided by Fort Pierce Utilities. As part of both of our North and South Hutchinson facilities, we provide reuse, tertiary treatment and public access reuse back to the residents within the service territory. In the North County, we maintain what we call the North County Water and Wastewater Facility, and that's where we're seeing the most of the growth occurring in St. Lucie County. So any expansion of utilities is occurring in the north. The areas on North Hutchinson and South Hutchinson Island, both facilities are currently designed permanent to handle all the growth of all the residents and future on the islands. So we don't anticipate any expansions of the facilities out on the Barrier Island. We anticipate the growth from a utility standpoint to occur in the blue, light blue area that we see on the map. Talking about the 5 facilities we operate, but break them down. South Hutchinson Island, that I talked about, we have a capacity of 1.6. We treat 12,200 residents on the island. North Hutchinson facility recently went through an expansion, so we're at permanent for 850,000 gallons, which will handle all the needs of the residents on North Hutchinson Island, and we service 7,400 customers on the island. North County wastewater facility was a utility that was purchased from a developer by the county, and we currently are permitted at 300,000 gallons per day. We service 4,000 customers in the North County, and we also have a water treatment facility servicing 4,000 customers in the North County. We have smaller facilities that handle flow from the regional airport, the industrial node at the airport, and a small utility that services 70 customers in the Lakewood Park area, which is 90 homes. Of that, when we look at this breakdown, we look on the South Hutchinson Island facility, we treat 171 million gallons a year in wastewater. Of that, 99% of it is treated to a tertiary level where it is pumped back to the residents to be used as a public access reuse. North Hutchinson Island facility, we treated 76 million last year. And once again, 99% of that went back to the residents as reuse. From those two facilities, on the South Hutchinson Island facilities, we created 181 dry tons of biosolids in 2018, which was land applied. North Hutchinson Island, we land applied 15.7 dry tons of biosolids, and in the North County, we treated 42 million gallons of sewage, and we dispose of the effluent there at a high-level disinfection to the adjacent golf course where it is utilized for reuse as well. And we produced a land application of 18.4 dry tons of biosolids at that facility. Currently, as we move forward, of our facilities, we are moving towards what we call on-site dewatering, using a mobile dewatering facility where we're taking the biosolids from the facilities from a 2% solids to a 22% solids, and we're having it removed out to a Class A or Class AA facility, biosolids facility, either Okeechobee landfill or the Brighton facility. So as we move forward here, we are going to be 100% moving all of our biosolids to treatment facilities and phasing out the land application phase of the operation. This is a brief statement of the future of Indian River, or St. Lucie County, Indian River. We're looking to do a water interconnect on the North Island to improve the redundancy of service for the residents. But we're also right now constructing water mains in the north part of the county along the Turnpike Feeder Road, US 1, to provide water service for the northern node of the county. Additionally, are currently under construction for a 16-inch water main and a 12-inch force main running out to 95 along the Indrio corridor. That will provide services for an additional 2,000 customers in the North County, where we're starting to see some growth take place. As part of that, we're in the process of expanding our north facility and our water and wastewater facilities in the North County to meet the demand for the northern part of the county. The overview behind there is a picture of our North Hutchinson Island facility that I talked about. As you can, just to give you an overview of the wastewater treatment facility, you can see the two bigger tanks that are covered. That is where the reuse is stored. That'll eventually be pumped back to the residents. The 4 tanks there that are brown, that is the activated sludge process. And the white cover, the tanks you see there, is what we call the digestion. And that's where the biosolids are stored in treatment for ultimate disposal. Here's a quick overview. I always like this one picture on the left. That's our North Hutchinson Island. That's the barrier island. That's a great picture of all the condos along the beach, our pristine beach. And also in there, over there to the left, you can see our wastewater treatment plant sitting right there in the middle. It's right adjacent to Pepper Park and the Seal Museum. So as you can see, we have to be a pretty good neighbor when we're operating a water and wastewater facility there on the island. And that facility will take care of all the needs for the North County. There are a few nodes on the island that are still on septic, and whenever they were to be converted, we have the capacity to take care of that. A few slides here from our baling and recycling, but the gentleman here always brought it from a landfill. perspective, but I come from a operations perspective. I'm a state certified A class operator for wastewater, and I want to just talk a little bit, because I don't think most people realize when we talk biosolids where they're coming from. The wastewater treatment facilities that we operate are what we call an activated sludge process. That is the most prevalent form of treatment in Florida for treatment of wastewater. Previously, there were other modes, rotating biological contactors, trickling filters, that didn't produce an activated sludge, didn't produce a biosolids. But over the years, as we became more stringent on how we dispose of our effluent out of the treatment plants, those processes did not meet the requirements from a BOD, TSS, and especially a nutrient loading. So in other words, when we're disposing of our effluent, we needed to go to a level of treatment that can meet those needs in our permits. Activated sludge is the most prevalent and the best way to do it. So as part of the process of an activated sludge plant, I'm an operator, and we like to call, we're sludge farmers. We're cultivating biosolids in our facility to treat the organics that are coming into the plant from the residents' homes. Part of that process, it's a biological process. The activated sludge eats, breathes, and multiplies. We have to maintain a proper mass balance in the facility between food and microorganisms. The food is the organic material that comes down into the treatment plant in the form of sewage. We separate the organics from the inorganics, and the organic material flows into the plant. The microorganism portion is the activated sludge that we are cultivating, and we have to maintain a strict balance of that material in the plant to keep the plant in operation with our permit and our effluent restrictions. If that balance falls out of whack, most residents, you never hear of the operators down at the plant. And you know, every utility we have in our area, the operators and the staff down at the plant do a heck of a job, because we know eyes, ears, okay, and nose. We don't like to be seen. We don't like anybody to hear us, and we obviously don't want anybody to smell us, okay? So if the balance falls out of place in that operation of that facility, you're gonna notice us. So we have to keep that balance, and also we'll fall out of compliance with our permits. We won't make reclaimed water for the residents, and they won't be able to work. So we have a delicate balance that we have to operate there. So what we have to do to maintain that proper food to microorganism balance in the facility, we have to waste sludge. We in the business, I've been doing this a while. We used to, it's called sludge. We call them digestions. It's gone to biosolids now, but we call it residuals. But we waste that material out at the plant. We thicken it the best we can at our facility, and then we ultimately have to dispose of that material, okay? That is the last portion of an operator's job. First phase is getting the material from the residents and protecting public health and the environment. Getting the material through the plant, meeting our permit levels, and producing a quality effluent that the residents can utilize for irrigation. The final phase of an operator's job is to make sure that he disposes of the biosolids out of the facility in obviously a cost-effective manner, but in an environmentally sensitive and within regulations. So that is the final phase for the operations of a wastewater facility. We're moving into newer technologies. Just briefly, when I first started in this business, we had a pit at the landfill where everything went out to the landfill, and the material was just dumped into a big lagoon. Septage, sewage, I mean, it was terrible. We've come a long way in the industry, especially from a reuse standpoint, operation of facility, but biosolids is the last phase that we need to become more of a good neighbor to the environment. And it's good to see that we're having this symposium from an operator standpoint. We need to dispose of our biosolids, and we want to do it in an environmentally friendly, but it's excellent to see so many officials in here that moving forward, we can come to a way of treating and disposing of the biosolids that is a good steward for the environment. Thank you.
Thank you, Pat. Next is Indian River County. Indian River County. Eric Charist is the Environmental Compliance Specialist for the Indian River County Department of Utility Services, and he's going to let us know what's going on in Indian River County.
Thank you. Thank you. I think I lucked out here by being the last of the speakers up here. My fellow speakers definitely laid out a great groundwork for my portion of it. So, in Indian River County, we have a water and wastewater services facility, services that we do supply drinking water and wastewater services to the residents of the county, excluding the city of Vero Beach. We're the unincorporated county with the exception of Vero Beach. This is just an overview. Like I say, everyone else has given a great description of what wastewater plants do. This is an overview of what Indian River County maintains as far as their wastewater treatment facilities. We do have 6 permitted facilities. Out of those 6, one of them is classified as a repump station, and one of them is just, we're maintaining a permit at this point here for potential future expansion. Out of the 4 that are left, 3 of them are what we would consider our regional facilities. That are the larger facilities. You'll see we have a West Regional, Central, and a South Regional facility. And those 3 facilities do put the product of their effluent, the reused water, into the system for the reused water. And their biosolids from those facilities are transferred to our regional dewatering facility. Out at the landfill, we actually have a facility somewhere. No. Our dewatering. All right, put that down. This is our dewatering facility. It is co-located at the Indian River County landfill. We actually own the facility, but the operations are contracted out to a dewatering company called Synagro. I think we've brought them up previously in the conversations. But Synagro maintains our dewatering operations out there. Indian River County basically brings the sludge to the facility, and it is dewatered. It's brought there probably in the 2% solid, like Mr. Pat was talking about, and when it is done through the dewatering process, we get it down to about 22% solid. That product there is then taken to our landfill and landfilled. Like I say, I apologize for the amount of detail on the pictures, but to tie in with Indian River County, this kind of goes back to a history about a couple of years ago. Indian River County has operated that dewatering facility and had received a lot of use. It actually almost functioned as a regional dewatering facility, which did contribute to erratic loadings at our wastewater plant. Because at the dewatering facility, the biosolids, the dewatered cake, is brought to the landfill, but the centrate from the dewatering facility is routed back to our West wastewater treatment facility where it is treated. The problem with not being able to control the loads coming into the facility, the dewatering facility, was that we could not control the centrate that was heading back to our wastewater plant, thus causing problems. Back in May of 2017, the county took a hard stance and actually put restrictions on what comes into our dewatering facility. And as you can kind of see in that graph, when we did so, we observed that about 2/3 of the waste brought to our facility, not from our own wastewater plants, but from independent haulers, was from out of county. Once we put the restrictions in, our wastewater plant came back in line, and the volumes were manageable at that point. I say that because we've been focusing on the wastewater plant with the residuals, but I also want to, identify that biosolids can also come from the processing of septic tanks and through the dewatering process. Indian River County has probably about 30,000 septic tanks, so septic tanks do need to play into this role as well as the biosolids coming from the wastewater plants. And again, this is just a quick overview as to the choices that were taken. Indian River County does benefit from the facility being co-located at the landfill, so we are not having shipping costs to actually landfill our product. We generate about 5 million gallons of influent in the wastewater on a daily basis, and on an annual basis, we put about 1,800 dry tons of processed biosolids into the landfill.
Okay, thank you. We have a few minutes for questions. If anybody has questions, there's a microphone over here.
Hi, my name is...
There's a little switch on the front, on the top, and you got to switch it on.
Okay.
Hi. Okay, it works now. My name is Mel Bromberg from St. Lucie County. I have a question for Ron Roberts. Good morning. You mentioned, I would like to know what % of the wastewater treatment plants were tertiary treated, and you did mention that. And then second, the extent of the new technology that you're using for getting up to tertiary treatment or wastewater plant treatment.
Currently, all of our regional facilities are providing tertiary effluent at a high level disinfection with filtration and providing public access reuse. In St. Lucie County, they are committed to any future expansion, any future facilities that are constructed will be 100% reuse back to the residents for irrigation. And as the facilities are expanded or new facilities are constructed, treatment processes for biosolids is going to be a very important portion of the design and the construction moving forward. The areas that we operate right now, we're on the barrier island, and to process biosolids on the barrier island with residents nearby would not be a good practice. So that's why we're contracting. We're moving our material to a biosolids facilities out in Brighton or did that answer your question?
I guess the technology also. What level technologies are you planning to employ, higher level technologies for treatment?
Well, we're already at the high level treatment for the effluent from a filtration standpoint. We're meeting the reuse criteria. You have to have what we call redundancy within the facility to meet the rules and regulations to provide public access reuse. We're already there on our facilities. Moving forward, then the treatment advances will be in the biosolid side. Whether it's done at the facility or taking it to a treatment facility, regionalized, either a public or private, that seems to be the trend right now, that the biosolids are being moved to treatment facilities in the western portion that are Class A or Class AA. That's the goal in the future.
Diane Goldberg from St. Lucie County. I have a question for each one of you. Maurice, first of all, I would like to know, you mentioned fertilizer blends, and I would like to know if the packaging has to show that it includes biosolids when that is a part of the blend.
Well, as far as our DEP rules, if a facility was going to directly market it, they have to provide the end user with that information. But if it's under fertilizer rules, nothing's really on the transaction between middlemen. So if it's transferred from, for example, New England Fertilizers to a fertilizer company, I don't know. But I think most of them are sold in bulk. And we don't have any requirements. I know, like in Tallahassee, there's a facility up in Georgia, Graco, they sell a bagged product. It's not clear, on those bags that it's sewage sludge that's mixed into it either. Mm-hmm. So our rule does not apply to those fertilizer companies once they get it in as a material.
Thank you. Hassan, in Palm Beach, is any of the waters clean to the effect where it is used at all for drinking water?
Are you referring to the drinking water?
Yes.
Yes. Well, drinking water, our source of drinking water is from Biscayne Aquifer and also from the Floridan Aquifer. So from 120 feet to about 1,400 feet below under ground surface. So the source of our drinking water is extremely safe. And then we also have the highest technology for the water treatment, membrane, ionics exchange. So maybe you could be a little bit more specific when you say, is it safe?
I didn't ask if it was safe. I just asked if any of the liquids from that are removed from the sewage, to make the biosolids, are pumped if they're used, if the drinking water is only from the aquifers,
Right.
are any of these pumped down into the ground where it can reach the aquifers?
The treated effluent from the treatment plant, they are pumped into the deep injection wells. So those are about 3,000 to 3,200 feet underground. They are actually way below the USDW, which is underground source of drinking water, typically at elevation of 1750. So our aquifers are much, much higher than where the water is being injected. There are many, many confining layers. So the effect of what we inject into the ground is non-existent to the source of drinking water. We also have the highest treatment capacity of the reuse water. We produce close to 24 million gallons a day of reuse water. We are one of the top in the whole state of Florida, just from one of our treatment plants. We have other facilities that we treat the wastewater to the high-level disinfection level, reuse, and we use them for many, many golf courses. In Palm Beach County, there are more golf courses in Palm Beach County than the whole country of France. So all these, what they enjoy actually are the reuse and kind of, I hate to say that, the nutrient in the water, that's what attract the reuse water to them. So from our wastewater plant, not the days like this, but on a dry season, we almost utilize the entire effluent that is being treated at the wastewater plant into the reuse system.
Thank you. Sam, you were talking about different sodiums using to raise and lower the pH, and I'm wondering how good these salts really are as fertilizers and how it would affect plants and wildlife.
Well, I will tell you from the start, I'm not a chemist or a biologist. We've been following a process that's been outlined and approved by DEP. There is an end product. We can produce two end products, a Class B or the Clean B or the Double A. Those are both accepted at facilities for further composting if that's their process. But as far as that, they seem to be regulated by the state and approved for that end use.
Thank you. And Patrick, I'm interested in what what you're doing. I'm really pleased about, but I'm wondering what our cities are doing, Port St. Lucie and Fort Pierce, because most of the areas in St. Lucie County are handled by the cities. One of the things that worries me is the McCarty Ranch, where they are putting in 6 reservoirs to take in water from the C-23 canal. And there was a recent article in the newspaper how that is one of the biggest areas that they're finding microplastics, which is an indication of seepage of biosolids, because I've been told by the DEP at a lecture by Emily Dark that the biosolids actually concentrates and takes out 99% of the microplastics from the water. And if that is the highest concentration, then it does sound like that's one of the areas where we're having a problem with maybe from the farms where it's being applied, that it's getting back into our canals. And the city has said that by 2035, they want to put in a plant to use this water. They're going to drain it into 3 shallow aquifers and 2 deep aquifers, and then use that for drinking water.
Thank you. Obviously, I can't speak for what the city of Fort Pierce and Port St. Lucie are doing. I believe Fort Pierce has a deep injection well for their effluent, and Port St. Lucie has a combination of methods for disposal. And there's some of their officials are here that you could probably ask them. I operate St. Lucie County, but I think your question is that what you're hearing. One of the trends in the industry moving forward is what we call water farming. In Florida, everyone looks at the state and they see all this water and they think that we have an abundance of water that can be utilized for drinking water, but it's mostly salt water. So to treat that water, we have to use high-level technologies of reverse osmosis to remove those salts. So, and then the other issue we have was the stormwater runoff reaching our water bodies, which is not a good practice. So in the industry, there's a move, and it's happening all around the country, what we call water farming. They're capturing the runoff, creating surface water reservoirs, and then using that as a water source for water treatment, as opposed to using the groundwater. Now, there's two methods of providing source water for water treatment. You either have an aquifer, the wells, or surface water. There's very few surface water facilities in the state of Florida. Mostly we're on groundwater, deep wells, shallow wells. But around the country, there's a lot of what we call surface water, where they're taking water out of a body and we're treating it to a level. In Florida, there seems to be some of that water farming that's in the planning stages. I don't know a lot about it, but it seems like a concept that when the industry, it will be done in a fashion that will be beneficial so that we're not discharging stormwater into our intercoastal. And also the level of treatment will be as per the state drinking water standards and the EPA standards. I'm also a certified water operator. So whatever your source water that you're utilizing to make water for your community, no matter where your source is, you still have to meet the Clean Water Act and the EPA standards for that water. So it's in the discussion phase now in Florida and around the country, and it's just a way of maybe utilizing the stormwater as a resource as opposed to just discharging it into a saltwater body. As water flows out, out of our ditches and canals in a freshwater state from rainwater runoff, it hits our saltwater body. That's a resource it's gone. Once it's in the salt water, to get that back as a resource for drinking water, we have to use a very high level of treatment, very costly. So people are looking at it as a way of capturing that water and using it as a resource as opposed to discharging it into our saltwater estuaries. Did that answer?
I think it's still, an issue waiting to see what will happen. Thank you for your comments.
We had time for one more quick question.
We've talked about the push for reclaimed water and the positive aspects of that, and the state does have a standard on reclaimed water, and I'm confident that all of you are meeting that standard. Most of us are aware that around the Chesapeake Bay, the standard for reclaimed water for nitrogen is about 1/10 of what Florida's standard is. That brings to mind the idea that our standard might be somewhat less than we need in terms of the nitrogen pollution in the estuary. My question for you is, as individual utility operators, have you voluntarily taken on any treatment processes that would reduce the nitrogen levels in reclaimed IQ water to well below what the state standard is?
I could speak for St. Lucie County Utilities on our reuse systems. We're operating to achieve less than 5 milligrams per liter of nitrogen, even though that's not a requirement for our public access. But when you get into wet weather discharge, we have to operate. If we discharge to a groundwater source or perk ponds, we have a nitrogen limitation. So we maintain that facility well below the standards for nutrients in our reuse.
We, as well as the other utilities, meet those minimum requirements. We are working on some processes to reduce that nitrogen level voluntarily. There is a cost associated with that. So we're in being good stewards of the environment and that as well, we're also trying to be good stewards of the public's pocketbook and our customers' pocketbook. So it's always a balancing act. But that is a good question. I think that's something we're all attempting to achieve as well voluntarily.
The same for Indian River County. We actually have one of our wastewater plants also has a potential for a surface water discharge. So we have tidal limits on that. So we actually run that plant even when we're putting into the reuse water with the tighter criteria. So we are below the state's limits.
Thank you. As I mentioned, we produce probably the highest gallonage of the reuse water in the Southeast Florida or even up to Orlando. But what we have done, we actually did a water quality testing. We have a lot of canals in Palm Beach County that they bring the water from Lake Okeechobee all the way. That was done 50 years ago or so for the agricultural purposes. So we measured the nutrient content, nitrogen and phosphorus, in the area that we have reuse, like when we have golf courses. The golf courses are always surrounded by the canals, one in the north, on the south, east and west, whatever. That's what they used to use water for the irrigation, either lakes, wells, or the canals. And we found out that the nitrogen and phosphorus level actually in the area in the agricultural side, I hate to mention or comparison, was much higher than the area that we actually put reuse water and they use for irrigation. Again, as this is true. I mean, you can, because we also had two constructed wetlands, Wacorahatcha and Green Cay. We put secondary effluent on those wetlands, and the goal is to hopefully, by nutrient removal, all the vegetation, and whatever we have, we could ultimately discharge the water from our wetland to the canal. That did not go well. However, as part of that, we did do a study, and we found that the agricultural area actually, or the runoff the nutrient, runoff from the fertilizer or whatever they do in the area that they don't have reuse is comparative or even higher than the area that they actually do use reuse. So maybe in the Chesapeake Bay area, maybe up north, but in our area, I don't think that reuse water is adversely affecting the water quality in the area that we serve.
Thank you. Thank you all for your interest and attention. We have a 10-minute break scheduled now, and we'll start back up again at, I believe, 10:30.